this is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see a topic on concepts of GIS that comes under the subject Geographical Information System for the students of third year 6th semester. Today we'll have a small overview on what are the foundational definitions that is involved in GIS, what are maps, and how the core map characteristics in GIS will be affecting and will be helpful for us in the applications of agricultural industry. GIS is nothing but a computer-based tool which helps us to capture, store, analyze and visualize spatial geographic data, and also these kinds of data are usually stored under two types. One is the vector data and the other one is the raster data. As we all know, vector data is nothing but the identification of geographical features. Okay, so geographical features is nothing but consider our college ground. Okay, what we do have at our college campus, we do have the buildings for every department, and also we do have canteen, we do have a ground, we do have cafeterias, and we do have the entrance lawn and everything. So here all the places have been located with the help of roads. Am I right? So the roads is nothing but a pathway which helps us to connect together or connect each other. So these are always represented using a line feature. So geographical features are represented, are converted into line drawings, point drawings and polygon drawings that are already available visually for us in a place. So here the roads will be converted into line, and then for the cities or for a building, what we are gonna do in the sense, the building is a closed structure, so building could be converted into a polygons, so that means it will show us a enclosed area. Then point in the sense that at the entire space, if we have to locate a place, for instance I'm going to locate our food court. So what I have to do for the purpose of locating it, I have to point it out. So then that place has to be marked in as points. So this is how the geospatial data will be converted into vectorized data. So similarly, the raster data is nothing but which will be converted into grid cells or pixels, which are commonly used as satellite imagery, aerial photos and digital elevation. Okay, so some of the examples that involved under these kinds of geographical information system are where we are gonna monitor the environment. So under the purpose of environmental monitoring, what we have to do in the sense, we'll track the deforestation with the help of satellite imagery. That is what I have given here. Okay. Similarly, at the urban planning, what we are going to do in the sense, we are going to analyze the land use with the help of vector data. At the disaster response, we are going to map the affected areas for aid coordinations, and also for the purpose of transportation, we are going to optimize the route with the help of network analysis. So the next part which I was going to take for you is map and their influences along with their history. History in the sense how the map has been available initially. Initially, the maps have been available in a clay model. So the clay tablets have been used for the recording of data. So the early maps are always called as Babylonian clay tablets, which are used for recording the earliest recorded maps. Next, we have been trying to incorporate the utilization of latitude and longitude. While we are studying under schools, we were known to read the latitudes and longitude of a location. So these kinds of utilization of latitude and longitude come into existence with the help of Ptolemy system that has been considered from 2nd century AD. The next third one is cartography, where we are going to use John Snow's cholera map revolutionized medicine. The next one is modern maps. The digital mapping advances GIS capabilities. So here I have shown you how we can interpret the map. The maps are usually in Mercator or Gall-Peters way. So the map projections are usually considered under these two terms. Mercator is nothing but here the shapes are always preserved and the areas will going to be distorted. Similarly, at Gall-Peters, the areas will be preserved but the shapes will be distorted. That means one is going to be kept as constant and the other one is going to be taken on our own. So if I'm going to use the Mercator map projection, here what I'll do in the sense, if the projection or the shape of a building will be considered same, but the area covered will be according to my own self. I'll convert them according to a scale. Okay, so under Galpeters, the area will be same, but the shape will be distorted according to the symbols. So this is how I have shown you here what is scale and a symbol. Scale is a thing which relates to the map to a real world distances. Similarly, symbolization uses shapes, colors and lines. Symbolizers are usually needed where we are going to convert the map into a vector data, because what I have said at the initial topic itself, vector data will be always considered of line, points and polygons, because whatever nature or whatever geographical features are available, we have to convert them into only these three symbols. So then only we can obtain the vector data. So the characteristics of map in Gis are dependent upon spatial accuracy, attribute accuracy and logical accuracy along with the completeness. These three accuracies plays a major role in quantifying the location in a precise manner and also validating them according with the help of range and checks, and also it helps us to prevent the contradictory between the spatial relationships. So if that's the case, what happens in the sense, we can ensure that all the features are properly represented in a map in a very minute manner. So this is how the map could be developed. So this is what I have prepared for today's class. If you guys have any kinds of doubt or anything, you guys can ping me anytime. See you at the next class. Thank you.